Okay, so today the only thing we really have scheduled is where are you struggling, what's going on, how can I help you, especially with the parts of the atom and then the neutrons, and figuring out atomic mass and all of that. So I need to kind of go into the chat and say where you're struggling. And those of you who are here because you thought we were going to feed the snake, nobody reminded me to bring a rat, so I did not bring the rat to video feeding the snake, but I will video that next time I feed him. Anybody there? All right, Sydney, you doing good on everything?
Can you do the isotopes? I think I got a 6 out of 9.
Sure thing. Okay. I can do that. Thank you. I'm always happy to help. All right, let me move this. Let's change my view so that you guys can see everything. Let me remember how to go to, I want to go to screen view. More security chat. I have totally forgotten how to do this. Hold on. More breakout rooms reactions. Share screen. Gosh, it's the green button right in the middle. All right, so we're going to go here. We're going to share. Okay, so isotopes were on page 212. Let's go over here. Let's go to our chem notes. Let's go to isotopes. Okay, so isotopes sound really hard, but they're actually really easy. When we're dealing with isotopes, all we're dealing with is an atom that has a weird number of neutrons. Okay, so this is loading. Give it a second to load. Okay, so when it has a weird number of neutrons, it shows up in the mass. Okay, so let's kind of skip through all of this stuff. Okay, so the mass is the protons plus the neutrons. Okay, remember it's an average mass because sometimes you have more neutrons, sometimes you have less neutrons. We talked about that with family sizes, like the average family size in America, the average number of children every family has is 2.3. Well, where do you store that 2.3 child? Well, the issue is that some families have 3 children and some families have 1 child. So that's the average. So what you're going to do is you are going to, if you want to figure out if it is an isotope or not, you need to compare the mass, the rounded mass on the periodic table, to the mass that has been given to you. When you compare those two, if those two numbers are equal, it is not an isotope. If those two numbers are unequal, it is an isotope. Okay? I always think isotope you or something like that. That just makes it a little bit easier for me to remember that they're different. I know that doesn't really help anybody else, but that's how I remember it. So if the mass that has been given to you is different from the mass, the rounded mass on the periodic table, it is an isotope. Now, if you need to figure out the number of neutrons, what you do is you take the mass given to you and you subtract out the atomic number, which is the number of protons. Once you do that, that will tell you how many neutrons it is. Now remember, atomic mass is number of protons plus the number of neutrons. Or if you have protons plus neutrons minus protons equals neutrons. So this is, again, one of those really easy things that sounds scary, but it's actually really easy. Let me write on the screen. Let me do this. I'm going to exit this out. I'm going to get it into write mode. I've been trying to get my other computer hooked up onto the web so I can talk to you guys on the web. Also, to let you guys know, those of you who have me for B, so you're going to be here on Thursday and Friday, I am not going to be here. So you guys are going to watch a video on building a Bohr model, and you're going to practice building a Bohr model. So don't be surprised that I'm not going to be there. That's right. Now, where's my little pen? Did I put it? All right. Trying to get this to switch to tablet mode right now. Okay, so let's say we have been given a mass of my periodic table. Okay, let's say we're doing carbon 14. So C14. Okay, now if we're doing isotopic notation, we would write C14. You're going to put the mass that you're given there, and then you're going to put the number of protons, which is the atomic mass, 6. So first of all, we need to ask, is this an isotope? Now, as I look at the periodic table says that the normal atomic mass is 12. So 12, 6, carbon. Now, this one is normal. So do you see these two numbers are not the same? So this one is an isotope, and this one is not an isotope. Okay? Now, the way you figure out how many neutrons there are is you simply take 14 minus 6 and that is 8. Okay? If you want to know how many proton or neutrons there are in carbon, it's 12 minus 6, and that is 6 neutrons. So this one is not an isotope, and this one is an isotope. Okay? Does that clear things up a little bit?
I'm sorry, can you do it again? I was kind of confused.
Absolutely. What part confuses you? Or all of it?
All of it.
Okay, so let's redo it again. I got all the time in the world for you. All right, so let's say we're looking at helium. Let's say we're trying to decide which helium is an isotope. So we've got helium 4. That means its atomic mass is 4. We got helium 5, and we got helium 6. Okay? When we look at the periodic table looks like this. Okay? It says 4.003. And then this is a 2 right here. Okay? Does that make sense now? If this number equals that number, it is not an isotope. So helium-4 is not an isotope. So N means no. Helium-5, those numbers are not the same. So this is an isotope. This number and this number are not equal, so that is an isotope. So helium-5 and helium-6 are isotopes. Does that clear up how to figure out if it is an isotope?
Yeah.
All right, so the next thing is, how do you find out what's the neutrons? So all you're going to do is take this number right here, and I'm going to change my color. This number right here, and you're going to subtract out that number. So 4 minus 2 equals 2 neutrons. On this one, helium-5, 5 minus 2 equals 3 neutrons. And on this one, atomic mass of 6, again, we're still minus 2 equals 4 neutrons. Does that clear that up anymore?
Yeah.
Okay. Would you like me to go over another example for you?
No, I think I got it.
Okay. What questions do other people have? Okay, guys, you got to yell out. You can't type it. Okay. So guys, all today is to catch up on anything you need to do. If you guys will go back and look at the home screen, look at A day and B day for your remote learning. Those of you who are coming in tomorrow, would you please make sure you have page 213 and 214 notes done. I will make a video tonight about what you guys are going to work on tomorrow, which is building Bohr models. And that talks about electron placements, which is, you just got to follow the map. It's no big deal. So if you guys have nothing else you need to talk to me about, I'm done. If you guys are all really comfortable with how to find protons, how to find electrons, how to find neutrons, how to find the atomic mass, and how to decide if it's an isotope. We're all done. Okay. Okay.
Okay. For the isotopes paper that I got like 6 out of 9, can I redo it and resubmit it?
Redo it and resubmit it.
Okay.
Absolutely. I am absolutely fine with that. If anybody's got anything they don't like, that they didn't feel like they did well enough on and they understand more, go back, do it, and resubmit it. I'm happy to grade again. Okay. Anybody need anything else? Okay, I'm going to sign off if you guys don't need me for anything else. I hope you guys have a great day. Be safe. Don't do anything stupid. Please wear your mask. All right. Have a good day, guys.